Okay, so this is a tutorial for the project assignment 1 for CS6353, and so throughout the semester we will be creating a compiler, and it will be divided into 3 parts. So for the first part, for this assignment, we will be implementing the scanner part of the compiler. And in order to do that, we're gonna use the help of 2 tools. One is called COP and the other is called JFlex to create this scanner. So basically it will scan the tokens, and then based on the rules we defined for the scanner to identify the terminals for our language. Lex is a Java Lexer generator. It is a tool where we can identify terminals for our language based on the tokens defined. And while COP is a parser generator. So we're gonna use both of the tools to complete our compiler. But for the first portion for this assignment, most of the work will be done on the JFlex part. So these tools, they will work on any operating system, but we do recommend you to use a Linux-based system, because that's easier for TA to run your project and to grade, and also because every student should have access through the UTD servers. And you will be provided a clean default project, and you can find it on eLearning. And both the COP and JFlex star files are already included, and also there is a make file to build for building the tools, and including the sample input and output. So you can find all of these things on eLearning. Well, so in this tutorial, we will use an example language to show you how to implement the scanner part of the compiler. But please be aware that this is not the language, the actual language that you will be working on for your project. So this is just an example language for demonstration for this tutorial. So the actual language you will be working on, the grammar of it is more complicated than this one. So, okay, let's take a look at this example language called UTD len-. So here you can see this is in the README file. This is the grammar of this example language. Break down the grammar into pieces so it's easier to explain. So this is the layout of the UTD len-. Basically it contains a list of routines which you can compare to the methods in any common programming language. And for each routine it has a routine name which you can compare to the method's name, and they have a list of arguments which include input and output parameters. So for the routines in this language, we don't have the return values. The output parameters is basically the returns. And then it has the body part, which contains a list of variables and a list of statements. And then we also have a main routine, a main method, which has a body that contains a list of variables and statement. As for the types of the UTD len-, there are 3 primary types, which are the number, string, and flag. So for the number, you can compare this to integer. For our program language, and the numbers can only be the whole number, but it can be positive or a negative. And the strings is just the strings. And for the flag, it can compare to the Boolean value. So for the true and false value, it will be up or down here. And yeah, also routines or methods, don't have any return types, as I just mentioned. And as for the statements, uttdlen minus minus support 5 statements. Each statement ends with a smiley face symbol. So there are the assignment statement, read statement, write statement, call routine, and the when statement. So assign statement is basically as you can see in this example, we assign integer 10 to the variable x, and then the read routine, write routine, and next is the expressions for uttdlen minus minus. So here is a list of the operators that we support in this language, which include the addition, multiplication, divide, and subtract, and then this flip and question mark. So addition can be done between two numbers or strings or flags, and the multiplication can be done between numbers and flag. Divide and subtract can only be done between two numbers, and flip it flip the value of the flag, and so up turn to down and down to up. And then the last one is the question mark, which is basically comparing the value of two numbers. It means it will return a Boolean value, and it means if the first one is greater than or equal to the last number. Extras to note is that, so first, our language support only whole number, only integers, so no decimals are allowed. And the results of the division will be truncated. But we do support negative numbers, like the -5 or any negative numbers. And the next thing is that the IDs can only be upper and lowercase letters, so no digits are allowed in IDs. And the last one is that for the strings, it cannot contain tabs or new lines, and the only escapable correct characters are the double quote and the backslash, which are denoted as backslash, double quote, and backslash, backslash. So the first backslash is used for escaping the next character. Now that with the language features explained, let's take a look at an example of the uttdlen minus minus. So here is a simple example. It has a routine called read and add. This is a routine name, and then it has a in parameter which is called to add, whose type is number, and then it has a out parameter, which name is value, whose type is also a number, and start and end here. These are the terminals in this language. And then the first statement is a read statement, which takes in a parameter called value. And then the next line is a assignment statement, and on the right hand side is a addition expression, which add the value and to add. And then is the main method here, the main routine. You see that start and end pair here, that enclose the body of the main routine. And the first line is the declaring a variable called addVar, whose type is number, and then declaring another variable called result, which is also a number. And then it's an assignment statement, assign number 10 to the variable addVar. And then it's a call statement. It's a call routine is calling the read and add that we just defined. And so the input parameter is addVar, and the output parameter is the result. And finally, we call the write routine. Now that we have the basic understanding of the UTD-len minus minus, next we will start to create the scanner of the compiler. So here is a link to a file called tokens.jflex, and this is the place where most of your work for the project1 will be done. And also this file is already provided in your default project, so you can just use it. You have a template here. Okay, so this is a basic layout of the JFlex. It includes 4 parts: the header information, the symbol constructors, and then it's the regex pattern and the lexical rules. So first, for the headers and the symbol constructor parts, you don't really need to change anything. It's the template, you can just use it. So for the headers, it's just preparing the environment and importing the cut runtime and creating the Lexer class to prepare for the project. And then it follows by 2 symbol constructors. So we'll be using the second one, which takes in the ID token and the value of the object. And the YY line and the YY column here, they are the current line and the column number, the position of the scanner. But for these 2 parts, you don't need to change it. You can just leave them there. They're already written. The next part, we will write the regular expressions to define the patterns for our terminals. But not all the terminals need the regex for, such as the read, when, write, like these keywords. Our scanner just read it in as it is. But for the terminals like ID, number, strings, these do need us to define the regular expressions. Okay, now let's use some examples to show how to define the patterns for these terminals. For example, if you remember, in the language features, we mentioned that the number in this language should only be an integer, and also it can support the negative numbers. So as you can see here, we have an optional minus sign, which represent the negative numbers, and then digits from 0 to 9 are allowed, and there has to be at least 1 digit. The next one is the IDs. So IDs, this one is simple. It can only be upper and lower letters, and digits are not allowed. So yeah, this one is simple. It should be lowercase from A to Z and uppercase from A to Z. Plus sign means there need to be at least 1 letter exist. Okay, and the next one, strings. So strings cannot contain tabs or new lines. The only escapable characters are the double quote and the backslash. So we define the patterns for string first. It's a sequence of letters enclosed by a pair of double quote. And then we define patterns for letter. So you can see here the new line is not allowed and the tab is not allowed, but we do support the double quote and the backslash. But because the double quote, we need to add a backslash before the double quote and the backslash to escape them. And inside the JFlex file, we need to add another backslash before each backslash and the double quote to escape them individually. So that's why here we have 4 backslashes instead of 2. So 2 backslash is not allowed, and the backslash double quote is also illegal because we need another backslash before this backslash and the double quote. Okay, and next we add the patterns for the white space. This one is also simple. And the next part, which is also the last part of the token JFX, we need to add the lexical rules in this file. So now that we have defined a list of regular expressions, so when our scanner scan a token and it match one of the patterns that we just defined, we need to return a symbol for it. So what we're gonna do is we will go through the language grammar from top to bottom, and then we need to identify all the terminals and add them as a lexical rule in this file. So these grammars are taken from that GitHub README file. So now what we will do is to identify the terminals from it. So how to do it? So a terminal is a symbol that cannot be decomposed anymore. For example, if script is a terminal, so the answer is no, because it can be represented as a listed routine and then followed by the main routine. So, and then if routine is a terminal, the answer is still no, because it can be decomposed as ID followed by input parameters and output parameters, and then start, body, end. But if ID is an terminal, the answer is yes, because it cannot be decomposed into any other symbols. So in this way, we identify ID and start and end as three terminals. So for the start and end, our scanner just read it in as it is. So here we're gonna use the constructors that we mentioned before. The new symbol constructor takes in two parameters. The first one is the symbol ID, which you give the name for it. And then the next parameter is the value of this symbol. So for start and end is what it is. But for the ID, we use the YY text to read in the ID. And then we keep going and identify the in terminal and out and the left parenthesis, right and parenthesis, and then the colon, and the three types: number, string, and flag. And finally is the main terminal. Well, so far we've done with the token JFlex file, and then let's move on to the next part. So you can find the other file called grammar.cop. So this file is provided in your default project. You don't need to create it. And at this point, the only thing you need to do with this file is to add each of the symbols we just defined in the token JFlex into the grammar.cop. And on this side, this is a screenshot of what it will look like after it's done. So the syntax is pretty simple. All you need is to add the symbols into this file. So basically our project 1 is done now. The next thing is to add the test cases into the makefile to test if the scanner works as we expected. So we're gonna build the project using the makefile. I believe most of you are already familiar with it, but I'll still provide a brief rundown of how the makefile works. So at the header part, we declare some variables that's gonna use for later. So we define the Java, JavaC, JFlex, and copjar, and then we have a list of recipes. So here we set the default recipe to the wrong, and by invoking it, as you can see here, it calls the wrong recipe, and the wrong recipe then calls the sample file.utd recipe, and here it execute the all recipe first, which will create the lexer and parser, and then to execute the rest of the command here. And here we also have a clean recipe, which just if you run make clean, it will clean up all the generated files and give you a clean project. And yeah, here this file variable. So at this point, we don't need to do anything here, but in the later projects, if you create more Java files, you will need to add them here. Okay, so that's basically it. This make file is also in the default project, so you don't need to change it. The only thing you need to do here is to add the test cases as a list of recipes here, like this example. Now let's look at some sample test files together. So this is an example of a test case, and for your project, you will be provided a list of test cases which test the different kinds of the tokens, see if the scanners can identify them as expected, and the output of your test case should look like this. So, for example, the first line, our scanner read in the identifier called sqrt loop, and it identifies it as the token number 4. And then let's go to the grammar cup file and find the token number 4, which is ID, and this is correct. This is what we want. And then let's look at another case. So at the second line, our scanner read in the value in, which is a terminal that we identified as in. But right now the scanner identifies it as the token 4, so which is also ID. This is not right. Something is wrong here. So this is the very common mistake that I want to point out and discuss here, so you can avoid in your own implementation. So the reason this happened is because our scanner read in a token, and it will compare with the patterns we defined in the token JFlex from top to bottom. And because in the incorrect implementation, the pattern of ID is defined before the token, the symbol in, so our scanner matched the in with the pattern of ID and then return it as an ID token, and then it will stop here, it will not continue. And the way to fix this is pretty simple. We should rearrange the symbols that we defined in the token JFlex by simply move the ID to the bottom of the list of tokens, and then this error will go away. Okay, now that we have implemented the scanner for our example language utdlen-, and then I want to go over the grammars of the actual language that you will be working on in this project, so you will be more familiar with it. So let's go back to the assignment document. So for your language, it is a program that include a list of member declarations, and then for the member declarations, it include the list of field declarations and a list of method declarations. And for the method declarations, well, for your programming language, it supports the return type. So not unlike the UTD-len --, we don't have the return type here. So yours is a bit more complicated. And then here, so there is an ID, which is the method name, and then it takes in the list of argument declarations, and then inside the body of the method, it has a list of field declarations, and then followed by a list of statements. And here, it specifies the type for your language. So in your language, there are 4 types that's supported: the int, char, boolean, and float. So your language support the float, but the UTD-len --, only support the integers. And then next is about the statement. So you have more types of statement that you need to implement, like if, while, and return, and print line. And following the language grammar, you can find additional rules here. So this is where you're gonna extract the information to create the regex rules for some of your terminals, such as the identifiers or the integer literals or the string literals, and to add into the token JFlex file. And after you've done that, you need to go through the grammars from top to bottom and identifies the terminal tokens as we described in using the example language. And this is what you will be provided on e-learning to start this project. So you will have a initial project that include, so as you can see, you have a make file here, and all you need to do is to add the test cases as the recipes in this make file, and then you are provided with the tokens JFlex file and the grammar cop file. So the templates are ready here. You can just add the content into these files, and the cop jar and JFlex jar are also provided. You don't need to worry about that. And also there is a list of test cases provided to you on e-learning, and these are the test cases you need to add into the make file. And so when you are submitting your project, please make sure that you also include the output of these test cases. This is very important because if the output files are missing, some points will be deducted. Okay, and yeah, last but not the least, about the naming convention of your submission. Please make sure that you include your net ID and your last name in your submission name, because it will be much easier for me to grade. And the last thing is that the due date is the March 4th, which will give you almost a month to complete this project one. Yeah, so this is basically it. That's the end of this tutorial, and good luck.